Okay, one thing that I am going to attempt to start doing more on all of these quizzes, as you may have noticed, is ask what's wrong with this, or how do I do, or how do I accomplish this particular thing. Prime example up here in the first two. How do you find the x-intercepts of a rational function in the form y equals p of x over q of x? And I'm not looking for type it in the calculator and hit trace. If you didn't have that as an option, what would you do? You can write it one of a couple of different ways. You can either say, well, I'm going to take the numerator and I'm going to set it equal to 0, and I'd figure out whatever values that has. That would be my x-intercepts. Or you could say, since it's written that way, set p of x equal to 0 and solve. Either one of those is legit. And it's something you should know how to do anyway, to not just completely depend on, I'm going to stare at the calculator, that's going to tell me where the intercepts are, it's going to tell me where the asymptotes are. You should be able to calculate these on your own without that, and kind of use the calculator as your backup check. So then the second one, how do you find the horizontal asymptotes? Well, that kind of depends. What's it depend on? It depends on the weight that you have, and we talked about that a little bit before. There's three possibilities here. There's equal weight when you have the same exact degree in both, where you would just divide the coefficients. Okay, I'll actually put examples on here. I wouldn't expect that you're going to, unless you wanted to use it to kind of prove your point. But if I had like 4x squared over x squared minus 3, my horizontal asymptote would be at y equals 4. Because I'd have 4 over 1 with my coefficients, and they're equal weight. They have the same degree in the numerator and the denominator. The other one that we have worked with mostly is what's called bottom heavy, the larger degrees in the denominator. When that happens, it's always at y equals 0. So like if I had something like 4x over 3x squared, larger degree in the denominator means I'm going to have a horizontal asymptote at 0. The other one that we do deal with occasionally, but not in the same way that you would in pre-calc, would be if something is top-heavy. For our purposes, we're going to say there is no asymptote. Because what you would get is what's called an oblique asymptote. It kind of runs at an angle, but we weren't getting into calculating all of that in here. Like I said, that'll be more towards pre-calc. And something like that may look like 5x cubed over x, where the degree is larger in the numerator than it is the denominator. In that case, you wouldn't have one at all for our purposes. So if there's a way you can communicate this, okay, the best way probably is just in words. Probably rather than trying to describe it with p of x and q of x. Like p of x is greater than q of x, therefore it is top heavy. It's just easier with the words. Oh yeah, now see, that makes life even easier. We're talking about this. Well put. Now that'll make a question like that very simple. They're like, yeah, it's right here. That sheet that we handed out last week. Hi. Okay, so then we'll get to our next part. We actually get to do something now. How do you find the vertical asymptotes of a rational function? Okay, here, if I haven't peeked on my sheet yet, we're going to set the denominator equal to 0. And then again, I may have 1, I may have 2, I may have none. It depends on what my denominator is. So basically what I'm telling you, before you even get into these, the information for the most part that's in like 4 and 5 and some of it even in 6, you should be able to figure out those blanks before you ever type anything in the calculator. Because that way the calculator is just kind of reaffirming whatever it is you just found. So like for instance here, I look at number 4 and I go, okay, horizontal asymptote. And I just got these notes up here that I've got. So I'm like, okay, let's see. What's the degree when I don't even have a variable at all? 0, okay? So if it's 0 on top and 1 down here, it's going to be bottom heavy. So I should, before I look, and I'm like, wait. You're like, oh, why is he doing this in the middle? Anything else I should probably notice? This shift that's going on, right? I can't assume that. It would be at 0 if that were our whole problem. But we've also talked about what shifts can do. If I have that plus or minus shift that's going on at the end, that's going to shift it from 0 to 3. Might not even be a bad idea before I start drawing to go ahead and get that in there. My vertical asymptote, we've talked about 2 different ways of finding. We've talked about how I can look at this like a shift. It's the opposite of what I would think with plus 2, so it'd be left 2. Or I can just set that equal to 0. So if I set that equal to 0 and subtract the 2, my vertical asymptote is going to be at x equals negative 2. And again, when I'm talking about an asymptote, I need to be sure I'm putting x equals or y equals, because they're not interchangeable, of course. Because if I flipped them around, I'd have a totally different answer. So once I have that, the domain and range should be fairly simple. Domain goes hand in hand with my vertical asymptote. All reals except whatever my asymptote or asymptote values are. And then my horizontal asymptote and my range go together. All reals except any values that my horizontal asymptote takes on. Once I get that stuff figured out, that's the point that I usually would go to the calculator. Even though, to be perfectly honest, I could just stick some numbers in and probably come up with an idea, but we'll keep life simple here. So, all right, I'm going to remember to get those in there. So we've got negative 5 divided by, notice I put the parentheses around the x plus 2, because otherwise the calculator won't consider the plus 2 part in the denominator. Once I close it, I'm fine. So anytime you see pluses or minuses with things, you might want to consider the parentheses if they're a binomial term. Now I'll take a peek at the graph because I want to see if everything I've done seems to look right. Okay, it looks like my vertical's at 3 or 2. There's a 2, yes, because that's 1, that's 2. And then it looks like my horizontal definitely isn't at 0, it's shifted upward. 3's looking pretty legit here. So let's look at our table and see, there's the error message telling me where my vertical asymptote's at, so I'm feeling good with that. And like we said before, when you're graphing, once you find the vertical asymptotes, the numbers right around there are usually the ones that are going to be the easiest to give you an accurate drawing. So for instance here, negative 3, 8. Okay, I'm a little above here. Negative 4, I'm at 5.5. Let's see what we do if we get one more here. And even if I went up to negative 5, I'd be up a ways yet. So I'm not going to be hugging completely this time. That 5 is kind of pushing it away. And then if I go the other way, oops. Harty. 0, 5. Let's get one more there. And really all I would need the graphing calculator for is to help me out with my branches some. Everything else I pretty much should be able to pick off of just a little bit of general knowledge that I've got. But I definitely need all of those things when I'm doing this. So, okay, let's see. Help me out here on 5. Yes, sir.
Horizontal asymptote is y equals 0.
Close. Yeah, because these are equal weight.
Oh.
So if they're equal weight, I need to take the coefficients and divide those. Now, if I'd have had like 2x squared in the denominator, then we'd have been bottom heavy and we'd have had 0. I'd have agreed with you. And that's going to go hand in hand with my range. So all the values except that 1/2. What about vertical? Either how or what it actually is. Close. That's part of it.
Negative 5 over 2.
-5 over 2. Because if I set this equal to 0, minus it over, there's -5, but I still got to divide by the 2. And if some of you want to make it -2.5, you can. And again, that goes hand in hand with my domain. We'll get that in. So, let's see. Again, when you see those binomial terms, we want to make sure they're in parentheses, because otherwise the calculator is going to think something that we aren't wanting it to. So I'll have my x plus 3 in the parentheses and the 2x plus 5. I'm going to take a look at the picture just to see if it looks about like it should. I see my asymptotes a little above the 0 here, so that looks good. And then my vertical's out here. Now again, I don't want to just make a sketch where this just looks like a heart monitor at the hospital. Okay, because that's not what my graph looks like. So when I go to my table, I'm not going to see right away where that asymptote is because it's at -2.5. Now, if you really want to see it, you can change your table set, so it'd be second window. You could change it to go by every half if you wanted to, because then you would get to see, okay, there's my -2.5, my -5 halves, that's my asymptote. And then I could go ahead and plot my other points from there. But remember, when you're dealing with these branches, they're infinitely going in all directions. So this does not stop at this. It's going to keep on coming down and coming closer and closer to my asymptote. Same thing on the other side. Can get a little tricky sometimes because this one is really tight. But those arrows need to be there and those branches need to continue going on and on. So don't let the picture fool you. You probably wouldn't get fooled on this part, but I can see how you could on this part if you were just thinking it stops right here. And it doesn't. It's just because the asymptote gets in there. I'm going to go ahead. I'm going to put my table back to 1 for now. All right, shrink that down. So one more here to play with. Yes, sir.
So I put that in. I never got it rolled like that. It just looked like it was supposed to.
If sometimes depending on like what you have your window set to, you might get to see the entire branch going down. Is a possibility if you're not at a standard window on something like
My
that.
window is standard.
Okay, we'll have to take a peek at that here. I'm going to make a note here on number 5 to go back and look. All right, so I get to this last one. Now I start to ask for some other things. like the X-Intercept. Now remember, I look up at the top and it says to find the X-Intercept, I set the numerator equal to 0. Well, 2 equals 0. That doesn't do anything. Okay, what that tells me is there's not going to be an X-Intercept. Now I could do that, of course, if I look at the calculator and see it never crosses the x-axis, but that's a faster way to do it. Vertical asymptotes. It's in a factored form. Leave it. Don't multiply this back out. Just set each of those equal to 0. So I have 2 vertical asymptotes this time. One at -1 and one at +4. And that also affects my domain at those 2 values. And usually when we get a double vertical asymptote going, means it's going to look a little strange. And then this one, if I were to multiply this out, would give me a quadratic. It would give me a squared term, which means my degree is greater in the denominator, which means it's bottom heavy, which means I'd have a horizontal asymptote at y equals 0. Now, the Y-intercept may be the one thing I would say use the calculator for. But to be perfectly honest, remember, when you're finding the Y-intercept, it just means you're finding the value where x equals 0. I could use the chart or just plug in 0 for each of these. 1 times -4 is -4. 2 divided by -4 is a -1/2. We'll check that in a minute to see if we're accurate, but that's one of those things I could do even if I wasn't playing with a calculator. So I get back here and I go, okay, this gets a little more interesting when we go to type it in. We need the double parentheses, because if we don't, again, we're not going to get out of the calculator what it is that we're looking for. We need to make sure the calculator understands we want both of these quantities in the denominator, not being multiplied in at the end. And just as we say that, I didn't have both of mine in. That's better. So double parentheses at the start, double parentheses at the end. And then again, we'll get a look here pictorially at how funky this looks. Horizontal at 0 looks good. Vertical at 1, vertical at 4. But again, my actual picture won't look this way. And if you're ever looking at these and you really want a closer look, you can go to halves or something like that. So I look, I'm like, okay, I got a vertical asymptote at 1. And I notice all of my points are like really, really close to 0. I'm like, this is kind of weird. I mean, it does seem like it's just going to go, but it's going to hit those, and then all of a sudden it's going to start taking this jump. And again, if you want to see the jump, you could just make your table set really small. Like if you did something like make your table set, I don't know, 0.1, you're going to get a lot of points, but you're going to start noticing that those values, as you start approaching your asymptote, see, like at -1.1, I'm all the way up to 3. So I'd be way up here. So if you need that visual look, that's okay, but I don't want you having to change table set every time you're doing it. But to see it occasionally is not a bad thing. But most of the time, keeping it at 1 is a pretty good idea. So then I look and I'm like, okay. So once I get past that, so 0, -1/2, and then they both go up to -1/3, and Then it's back to -1/2, which kind of gets me that look that a parabola would. And then I head to the other side. And similar to what I found over here, they're all really close to 0 unless I had a very small detailed table set. But under no circumstances are my branches ever going to stop. I'm always going to have those arrows. There you go. But again, on all of these values should be pretty simple to come across without having to mess with the calculator too much. Here, we're just going to do a little sketching. For each graph below, sketch any vertical or horizontal asymptotes and give their equations. So in other words, if they're vertical, it should be x equals something. If they're horizontal, it should be y equals something. So like if I said on number 7, you've got one vertical and one horizontal, what would be those two equations? Yes?
Okay, and then y equals 2.
Yes. Because I can either visually kind of look at it and see that, or I could use my rules that I know. Set the denominator equal to 0. If 2x squared equals 0, then x squared equals 0, x is 0. These are equal weight. Divide my coefficients. 4 divided by 2 is 2. So draw them and write the equations. What about number 8? One asymptote.
I'm guessing it's y equals 0.
Y equals 0. Because this time we are bottom heavy. Larger degree on the bottom is going to be y equals 0 unless there was a shift at the end. And if you attempted to set this equal to 0, you'd only get imaginary solutions. Because I can't find any pair of numbers that multiply to 1 and also add to 1. So there is no vertical asymptote this time. So you can do it algebraically, and you can also kind of eyeball it and see that. Ooh.
That's almost the samples.
What about number 9? We have several this time.
I'm guessing -2 and 2 for x.
Okay, so x is positive and -2, because if I were to solve this, set it equal to 0, I'd have x squared equals 4, so which is plus and minus 2. I'm with you. And then I agree, I heard y is equal to 1. Because they're equal weight, so I'll just divide their coefficients. Very nice. All right, let's see what else we got to play with here on the back. Oh, more graphing. All right, now here we've got a laundry list of stuff to do. State the x-intercepts, vertical asymptotes, horizontal asymptotes, y-intercept, any holes, graph the function, labeling the asymptotes and x-intercept. Holy cow. Okay. So first thing, x-intercepts. How do I find those again? Flip back over to number 1 if you need to. Set the numerator equal to 0. So go ahead, I'll add my 1 over. So it looks like I have x-intercepts at positive and -1, or so we think, but I won't say any more for a minute. Letter B. Vertical asymptotes. How do I find those? Set the denominator equal to 0. Not going to draw that quite in yet. I'm going to find all my info before I start putting things in. I should have done that with my intercepts too, but I'll find that out in a minute. Okay. Horizontal asymptotes.
Are there? Oh, 0.
We're top heavy, so what's going to happen? There's none. We're top heavy. Y-intercept. Remember, when you're doing the Y-intercept, we're plugging in 0 for x. So if I do that, I just end up with -1 over +1, which means my Y-intercept should be at -1. And then the fun starts. The x-coordinate of any holes. Now remember, the only time a hole comes up is if you can find a factor that's common in the numerator and denominator. Oh yeah, factor this. X plus 1, x minus 1. I look and I go, hey, they have a common factor. The common factor is x plus 1. Means I have a hole at x equals -1. Now that means two things for me, actually. First thing it means is that point's not there. Second thing, more than likely, is going to be, when we look at the picture in a minute, that I'm not going to have an asymptote there. But let's check and find out. You're like, dang, so I need to start making sure I'm factoring these before I ever start filling out this other information. You're like, it's a straight line. Yes, because basically if I factored that, those could cancel, and that's just the line x minus 1. But here's what I have to watch for. It's not as simple as just drawing this line x minus 1, because there's a hole at -1. So here's the deal. I'm looking at all these other values, and I'm like, but it makes a straight line everywhere else. Right. But where that normally would go through here at -1, -2, it's not going to. Otherwise, this does become linear. So when I go back, I have to go back to letter B too. Vertical asymptotes. I don't have one here anymore. When that hole popped up, that took my asymptote away. So I have to be cautious when I'm doing this, even though it's good to think about it that way, but can I factor something to make it change the way that it looks some? So a little bit of pondering there, but we fought our way through. You're like, okay, so what can I do here? No Band-Aid violations. Do not try to call those a common factor and cancel. That guy's locked in. Okay, no canceling there. So I start to look. I'm like, okay, X-intercepts, numerator equal to 0. Okay, 0. And I already saw this time I'm not going to have holes, so I'm feeling a little safer this time doing this. Vertical asymptotes, set the denominator equal to 0. So I'm going to add one at x equals 2. What about horizontal? Equal weight. So it's going to be at 1. Because they each have a coefficient of 1 sitting there. Good. My y-intercept, if I plug in 0 for x, if I plug zeros into both of these places, 0 divided by anything is 0. Huh, same place. What a coincidence. And then we already said, if you don't have a common factor in the numerator and denominator that cancel, like we did over here, we're not going to have any holes. It's like, well, this could look kind of weird. Let's see. There's my vertical asymptote at 2. Feeling good about that. Looks as though my graph's going through at the origin, so that would go with my x and y intercepts both being 0. Okay. So let's see here. So 1, -1, 0, 0. There we go. Notice as I start heading negative, get my other asymptote in here so I don't do anything bad. Get my branch in there. Go to my other side of my asymptote. Get my branch drawn in. And it's never bad if once you get these drawn in with the values, you go back and you look and you're like, yep, that looks good. Bless you. But again, I can take my general knowledge, but I want to be a little cautious. And again, that's where the help sheet kind of comes in handy. If you're not sure on something, double check. So then, 1 to go. Besides our question at the bottom. Looks similar to this one, except there's a couple of main differences. One of them is the very first question. If I try to set 2 equal to 0, that doesn't work. Not going to have an x-intercept this time. I'm still going to set my denominator equal to 0 to get my vertical asymptote at 2. What about horizontal this time? Are we equal weight? Are we top heavy? Are we bottom heavy? What are we? We're bottom heavy, which means we're not going to have any. We're only going to have 0 if we're top heavy. Oh, what did I just say? If I could, hang on. Yeah. Oh, I need to write these things out so I can see. Bottom heavy. There's one at 0. Now I would have seen that. I would have seen that in a minute when I actually drew it out. But instead of going to my brain of knowledge, I went to my brain of lack of knowledge on that one. So y equals 0. Since we are bottom heavy, I know better than that. All right, y-intercept. Now I'm getting frightened. Plug in 0 for x. 2 divided by -2 would be -1. And finally, any holes? No, because we don't have a common factor. Because again, do not cancel those. All right. Now we're ready to go get assistance. Some of you say, Harty, you needed assistance a long time ago. Yeah, sometimes. That's why it's good to try and write these things down before you go to the calculator. Because then, if we wouldn't have caught that, we would have caught it here in a minute. Except for the fact we need to get, there we go. I'd have caught it here where I've been like, oh, wait a minute, there is an asymptote along here at 0. Yes. And 1 at 2. Yes. And then there's my y-intercept, so that looks good. Get my asymptotes in here. We'll come back to that in a second here. So I start looking at this and I go, okay. And I start to peek and I go, this looks kind of interesting. Somebody wants to say it, but they're scared at this point. You're like, Harty, are you back in Algebra 1? You plotted your y-intercept on the x-axis. Yeah, I did. I'm admitting to it. Because I'm like, how is my asymptote going through there? Because I'm a bonehead. That's how. So, now that we've gotten that out of the way, that point really isn't there. You don't see it. You're like, sure we do. Both sides of my asymptote here. That's better. Looks much better once things are done correctly. This could be one of the more fun videos that ends up online ever. Just goes to show that when you think you know things and you go breezing along too quickly, even the people who should have the best grip on this can make an error, or two, or three. So let's see. When does the graph of a function have a hole? If you were asked to describe that, how would you do that? All right. We have a common factor in the numerator and denominator. That's why we always try to factor first. Well said. And like I said, as always, the quiz will look very similar to this. I may stick a review question or two from prior sections on here, but otherwise that would cover it.
So you are passing out this paper, right?